Bismillah ar-Rahman ar-Rahim. We continue our talk about Unit 6. So far, out of the three sections covered in Unit 6, we covered modeling of ROMs, and we started talking about modeling of sequential circuits. We already covered flip-flops, registers, and we just have one slide left on shift registers. And the rest of today, and probably Thursday, depending on how we progress, we'll be talking about counters. The last 2 weeks, we will be talking about modeling of any custom finite state machines. I think we stopped at slide 38. Yes. So just a quick review about the code for a 4-bit shift register. And this should be a 4-bit shift right register. So in your module, we're gonna declare input R. This is 4-bit input R. And we have 3 control signals. We have not basically control signal. We only have L as a control signal. This will indicate if this register will be shifting or it's going to be loading whatever you have present in your input, which is R. We have input W. This is corresponding to your serial in input. This is what you will be shifting in. And of course, for any sequential circuit, you should have your clock signal. Our output is Q. That means we can read the data parallelly out of this register. It's going to be 4-bit. That's the same size of the input load. And then always add the positive edge of clock. First, we're going to check the signal L. If L equal to 1, that means we will be loading. If we want to load to a register, we'll just assign whatever we have at the input to be assigned to the output Q. Now else, that means if L is equal to 0, meaning I want to shift. So if L equal to 0, the contents of the register are shifted to the right. It's important to note that if this is a shift right register or a shift left register. Now, and the value of W, the value of input W, which is serial in, will be loaded into the most significant bit Q3 because we are shifting to the right. So if you write your number Q3, Q2, Q1, Q0, and then you want to shift right, that means Q2 should read Q3, Q1 should read Q2, Q2 should read Q1. Wait, that should be Q3, Q2, Q1, Q0. So Q3 is going to be reading from W, Q2 from Q3, Q1 from Q2, and Q0 from Q1. And this is your assignment here, which matches our expectation. Okay. Now, how this circuit would synthesize? We'll have 4 registers, or sorry, 4 flip-flops. This is going to be Q3, Q2, Q1, and Q0. And since Q0 is reading Q1, so it will be connected to Q1 through this multiplexer. Q1 is reading Q2 through this path. Q2 is reading Q3 through this path, and Q3 is reading the serial input through this path. Now the selection for this mux is going to be our signal L. We said if L equal to 0, shift right, and this is what's happening here. Now if load equal to 0, I'll be selecting input 0 for all these multiplexers. And what happens if L is equal to 1? We want to load whatever we have in register R. So all the inputs of connected to the input signal of the mux at 1, that's going to be your R3, your R2, your R1, and your R0. And we named our serial input W from the previous slide, and this signal is the same as L. One more thing, you need to take out from the output of each flip-flop give you from Q3 to Q0 in case you want to read the content of this register at any time. And don't forget the clock signal. Okay, we might give you a sequential circuit code for a shift register or a sample register, and we ask you to draw the circuit that this code will synthesize to. Okay, so this is what we covered at the end of last class, and like the case that we did with registers, we wrote a general code for a register, an n-bit register. We're gonna write a code for a generalized n-bit shift register. One thing to note here that this is gonna be shift right register. I'm not sure why these slides are not mentioning that, but this is a code for a shift right register. So for any general code, this you take it as a general load. If you're writing a general code, you must have a parameter n. After this line, after you define parameter n to any number you want, anything from here to the end of your code should not depend on this number. It should depend on n. Why? The idea, if you want to declare any size shift register, you just copy this code and change this number to whatever size you want. Here we declared n equals 16. That means this is a 16-bit shift right register. Now, if I want an 8-bit shift right register, all I need to do is I come to the code and change this to 8. So the remaining of your code should work with the value n. Okay, so for example, our input, first of all, this shift right register, you need to make sure you know all the signals. So we have a clock, we will have input L, just the same as the previous design. When L equal 1, we want to load, and when L equals 0, we want to shift. And we'll have an input, a serial input called W. We have from 0 to n minus 1 input. This is what we want to load. And we'll have output from 0 to n minus 1. This is Q, and this is R. Okay, so this is how our general shift register looks like. Now, the declaration of the input and output is going to be the same, except that we're going to use the value of n to determine the size. So for an 8-bit register, your vector should go from 7 to 0. For a 16-bit register, your input goes from 15 to 0. That means if you want to generalize these numbers, it's going to be from n minus 1 to 0. Okay, that's why here the input is declared as a vector from n minus 1 to 0, same as for the output from n minus 1 to 0. Now these are only 1-bit signal, as you can see from this figure. We have L, W, and clock. That's common for any sized shift register. The only difference in this code in declaration of inputs is an integer k. Why we need that integer k? Because we are unsure of the size of this register. So we cannot just simply write the code in terms of whatever value of Q that you have. Here we know that this is a 4-bit register, so I just list the assignment of Q3 to Q0. In this code, no. We are depending on the value of n. And n is unknown to the code unless you declare it. So this integer k will be used inside a loop to make the assignments. Now, start with the always block, and we're going to be reading on the positive edge of the clock. First, check if L, that means if L equal to 1, we want to load. Here, I don't need to depend on the value of n. Whatever the value of n, it's already declared here. So Q takes on R, that's going to work for any size without mentioning the value of n in this statement. Okay, if you declare it as 16, that means Q is a 16-bit and it's going to be reading an input of a 16-bit. This is possible because we already declared the value of R and the value of Q depending on the value of n. So we don't need to worry about it in here. All right, so else, that means if L is equal to 0, we want to shift right. So what's happening in shift right? Write your number, that's Q n minus 1, Q of n minus 2, Q of n minus 3, up until you reach Q1, or let's say Q2, Q1, and Q0. Try to recall what we are doing in shifting right. So when you shift right, Q of n minus 1, this will take on the value of W, which is the serial n. Q of n minus 2 is reading Q of n minus 1. Q of n minus 3 is reading Q of n minus 2. Up until you reach here, Q2 is reading Q3, Q1 is reading Q2, and then Q0 is reading Q1. So obviously, we can write this in a loop. So we will start from k equals 0. K is less than n minus 1. That means this loop will stop at k equal to what? N minus 2. And then increment k by 1. Okay, so this loop will go from k equals 0 up to k equal to n minus 2. Okay, so what we're doing here, first, this is the easiest one, that q of n minus 1 is reading w. For the rest of those, I need q of k. Let's take an example. So if k is equal to 3, so what does q of 3 is what does q of 3 read in a shift right register? شباب.
سيريال ان يا دكتور.
لا k مش n, k equal 3. انا بتكلم اذا كانت الريجستر 16 بت، عندي 16 بت ريجستر، انا بتكلم عن Q3 هذه. في الشيفت رايت Q3 what is it reading? Is it reading Q2 or it's reading Q4?
Q4.
Q4. Q4. So if k equal to 3, when my loop is working and it reaches k equal to 3, the statement here should be Q of 3 is equal to Q of 4. Now take this back to the value of k, because I'm working on k in the loop. So Q of k is equal to Q of k plus 1. Take another bit, let's say Q of 12. So Q of 12 should be reading Q of 15 in a shift right register. So if k equal to 12, I should have Q of 12 equal to Q of 13. That means Q of k is reading Q of k plus 1. Okay, so this is the sentence, or this is the assignment that you need to do in your loop. So come back to your loop. You'll find that Q of k will take on the value of Q of k plus 1. Now, when you use inside the loop, when you use k plus 1 or k plus 2 or k minus 1 and k minus 2, you need to check that if this statement will execute as you expected. So check the corner cases. Check the beginning of the loop is 0 and the end of the loop is k is equal to n minus 2. So if k equals 0, this will become q of 0 equal to q of 1, which is correct. Now check for n minus 2. That's going to be q of n minus 2 is equal to q of n minus 1. This is also correct. We're left off with q of n minus 1. This will read the value of w. طبعا one thing to note here that this statement is outside my loop. How do we know that? Because my for loop does not have a begin end statement. So if you write for and then one line, it will just take this line inside the loop. If you want to make it more elaborate, you can write begin here and then end here. Okay, this assignment is outside the loop. I mean, even if it was inside the loop, it's not going to affect anything because it does not depend on the value of k. But what's going to happen is that it's going to assign w to n minus to q of n minus 1 every cycle. The result will be the same anyways. So what I mentioned before, انك you check the corner cases of your loop. Let's say you by mistake او يعني يمكن من العادة انك you go k equal to 0, k is less than n, k plus plus, and you write q of k is equal to or takes on the value of q of k plus 1. Now if you didn't check for the corner cases, let's check what happens at the end of the loop. What's the final value of q for this loop? K is equal to what? The final value of k.
كيف
15.
سالب واحد
واحد. إذا كتبت خلينا نفترض أن عندي لوب k equals 0, k is less than 5, k plus plus. How many times will this loop execute?
4 times.
4 times. 0, 1, 2, 3, 4. So 1, 2, 3, 4, 5 times. Is it going to execute when k equal to 5?
لا.
لا. ليه؟ لأنه الشرط is k is less than 5. If I have equal here, that's different story. Okay, so if 5 is equal to n, that means the final value of k for this loop is going to be n minus 1. So it's going to go from k equal to 0 to k of n minus 1. Now check when k equals 0, you have q of 0 takes on the value of q of 1. This is okay. Now check for k equal to n minus 1. This will be q of n minus 1 takes on the value of q of n minus 1 plus 1. That means q of n minus 1 will take on the value of what? Q of n. Do we have q of n in our design?
لا.
ايه this statement will be يعني اذا بتتكلم عن الجافا حيعطيك array out of bound exception. هذا في الجافا. هنا we don't have q of n لانه q is declared from n minus 1 to 0. This is why this limit is n minus 1 instead of n. So this loop will go from k equals 0 up to k equal to n minus 2. If you wanna change this loop to use the equal signs, you can write for k equals 0, k is less than or equal to n minus 2, k plus plus. Oh, k equal to k plus 1. I'm not sure if maybe some version of Verilog does not read the k plus plus assignment, so you have to write k is equal to k plus 1. Okay. And this is the general code for any shift right n-bit shift register. Okay, you have to use a loop for that because we're unsure of the value of n. Everything below this line has to depend on the value of n. And this is applicable for any questions in this course. مو شرط في الشيفت ريجستر. ممكن يجيب لك اي سؤال. مثلا اعطيك اقول لك ابغى n bit carry ripple adder. Did we do that in the homework?
الظاهر إيه.
I think we did that. اي صح صح. كان عندنا سؤال عن الفول adder and this full adder has to يعني be الcode for this full adder has to be a general code. Anyways, just keep in mind that for any general code, anything beyond this line has to depend on the value of n. Okay, don't use the value of 16 anywhere and don't depend on it, because the idea of this code is by only changing this value, I can get any size I want. Okay. Now this slide is a little bit late. We already covered a 4-bit shift register and a general shift right register. That's just the same. It's only a shift right, 3-bit shift right register. This is a 4-bit shift. Let's see. I think this is a shift left register. So Q4, we have Q4, Q3, Q2, Q1, and your input is coming into Q1. So your input is coming in here. And then Q2 is reading Q1, Q3 is reading Q2, Q4 is reading Q3. So what's happening here is a shift left operation. This is a shift left operation. And it should say that here. All right, so generalized shift register with parallel load. This is what we were doing. And we said if you have a parallel load, this is, if you have a shift register with a parallel load, this can be thought of as a parallel to serial converter. When load is equal to 1, just load the value, and when load equal to 0, work as a shift register. How to make it a parallel to serial converter? All you need to do that you restrict the reading of your register from the final bit. The most significant bit in this case is going to be serial out. Parallel to serials mean I have the data, I will load it in parallel, and I will read it in serial. Now, shift register can also be used as the other way around, serial to parallel converter. How? I will apply the data in serially. If I have 4-bit, افترض عندي 1011, and I'll apply it serially in this register. So after 4 cycles, this register will hold the value 1, this register will hold the value 1, this will be 0, and this will be 1. After that, from here, I can read it out in parallel. So the same register can be used as a parallel to serial converter or a serial to parallel converter. Now these namings are very important. Why? Because I can ask you in the question, I can just write design a 16-bit parallel to serial converter. And you should know what to do. Parallel to serial converter mean I need to make a shift register. Okay? So in serial to parallel, I will apply CN and I will read the output in parallel. Parallel to serial converter must have a load signal. So I can load the data in parallel and then read it out serially from either the most significant bit or the least significant bit, depending on what you're designing. If you're designing a shift right register, you're going to read the data out from most significant bit. If you're if you are writing a shift left register, you're going to read from the least significant bit. Is it? Wait, اللي عندي Q3, Q2, Q1 and Q0, and you're applying serial in from here. Yeah, you're going to be reading. Okay, and if you're using a shift right register, it's the other way around. If you're using a shift right register, you apply serial in at the most significant bit and read serial out from the least significant bit. If you designed a shift left register, your serial in is coming into the least significant bit, and you will be reading the data out from the most significant bit. Okay. Now this is a Verilog simulation of the general shift. Is it shift right or shift left? So if load, whatever else, Q of n minus 1 takes on minus 2 and serial in. So serial in is coming into Q0. That means this is shift left. So this code is a shift left general register. Note that this register will have parallel load and the reset signal. It should also say that this reset signal is an active low asynchronous reset signal. So asynchronous reset signal, is it active low? Sorry, it's active high. So if it's an asynchronous reset signal, in my sensitivity list, I should have the reset signal. If it's active high, that means I'm going to use the positive edge of reset. And in any case, if you have a reset signal, this is what you should check first. If reset. So if reset equal to 1, I want to set the value of Q to 0. Else, here where you write the rest of your code. So the rest of the code, if load is equal to 1, that means I want to parallel load. So Q is equal to D. Actually, you don't need to write that. You can just write Q takes on the value of D. Why is that? Because Q is defined as from n minus 1 to 0, same as D. And it's actually the same as we did here. So just write Q equal takes on the value of D. This is also correct. You can replace this statement. Here, you can also write Q takes on the value. Now, you can do that. You can do the general shift register without using the loop. How can you use that? Is using concatenation. So Q here takes on the value. Let's check it out. It will take from Q of n minus 2 up to 0 and concatenate serial into that. Let's take an example and see how it works. So let's take a 4-bit register. Q3, Q2, Q1, and Q0. Okay. And I'm shifting left. Okay. So my output, your output should be the value Q3 should take on the value of Q2. Q2 should take the value of Q1. Q1 takes the value of Q0. And then Q0 will take the value of what? Of serial in. معايا يا شباب? Is this
معك.
clear? Okay. طيب. Let's see what this code does. هذا الكود بيقول لك انه Q equal to Q of n minus 2. احنا n عندنا 4. عرفنا n as 4. So Q equal to concatenation between Q of n is equal to 4 فمعناته this is 4 minus 2, so this is q2 to 0, and I will append the value of serial n here. So q is equal to what now? Equal to q2, q1, q0. This part is, I'm just breaking the vector, and I will add Sn. What's q here? هذا الq هي q3 q2 q1 q0 equal to q2 q1 q0 and Sn. These two together, these two together, q0 to q1 and serial n to q0. Match this against that, you're going to find that these are the same. Okay, so instead of using a loop, what it did here is that I used a simple line of concatenation between the previous value of q and the new value of q. Now, regarding this register, I declared an output called S out. So S out is just the serial out. How do I read serial out? In a shift left register بهذا الشكل. Shift left register, that means I am applying serial in from here and I'm taking serial out from here. بالتالي my serial out is the value of q of 3. This is in a 4-bit register. In a general register, what's q3 compared to a 4-bit? This is q of n minus 1. So that's what it's doing here, a simple assign statement. I will assign S out to q of n minus 1. Now note that this assign statement is outside your always block. You cannot use assign inside the always block. Anything inside the always block has to be a procedural assignment statement. This is not a procedural assignment statement. This is a concurrent assign statement. Okay, this is a simulation. Let's try to go through it. This is the signal load. This is reset and clock. So clock is just going 1 to 0. Serial n is 1. That means I will be appending 1 when load is equal to 0. So here load is equal to 0. No, wait. Load is equal to 0 for this part. We need to read this the signal. ففي البداية I think did it reset? It did not reset at all. So reset is not connected. Okay. That means he is never resetting the circuit. هنا في البداية عندك load equal to 1. So when load equal to 1, the value of Q اللي هو output أو content of your register is gonna read the value of D. D in the beginning was set to 0, 1, 0, 1, 1, 0, 1, 0. This is the value of D. If this is the value of D and I put load equal to 1, that means the next positive edge of the clock, check out the value of Q. This is equal to the value of D. Okay. After that, load went to 0. معناته from now on I will be shifting. So check for the next positive edges of the simulation. We will be appending the value of serial n to the register. Where am I putting serial n? N q of 0. فلاحظ هنا الان load equal to 0. تعال لهذه البوزيتيف edge. load equal to 0 معناته أول شيء I'm shifting. At this edge I am shifting. طيب, you're shifting left because my code is shifting left. What's the value you're shifting? Read the value of serial n. هنا serial n equal to 1. معناه I started with 0, 1, 0, 1, 1, 0, 1, 0. if I'm shifting this value to the left and serial n equal to 1, what's the result? It's going to be, if you add it from here, the final value should be 10110101. This is the value after shifting 1 to this register. تمام? Now match this number with this one here. You're going to find that it's correct. 10110101. طيب. Next clock cycle. Load is equal to 0 معناته I am shifting. طيب. What are you shifting? Read Sn. Sn equal to 0. So this is the previous number now. And we want to shift left by 0. That means the result should be 011, 0101, and 0. Match this value to this value. And you'll find that it's correct. And you can keep going. Okay. If somewhere in this circuit كان عندي reset when going from 0 to 1, whenever the reset goes to 1, it should have shown this example. But whenever CN goes, whenever reset goes to 1, at this edge, it's gonna go into the value of Q and make it all zeros. ليش؟ لأنها asynchronous reset. It's not a synchronous reset. It does not depend on the clock. So anytime in your simulation, if reset went from 0 to 1, it will take this edge according to this code. It will go inside and will check that reset equal to 1, and it will make Q equal to 0. Okay. It should have shown this in the simulation, I think. Actually, let's move counters to next class, and maybe we can write this code to see the effect of reset. Can I copy that? Yep. Okay, so we'll have our module shift register. Let's make sure that have clock, reset, load. Okay, هذه كلها declared inside inside it. That's fine. Now input clock, reset load, serial n minus 1 كذا كذا, and n equal to 8. So always add, yeah. Okay, we'll just use the same code and write a test bench for it. So let's write module test. Can you see my window يا شباب ولا؟
ايه
طيب, and module. So here I need to declare rigs for those. Control H here. No. Rig n equal to come 8, so this is 7 to 0. Also a rig for this one and a rig for that one. Clear things up a little bit. If you notice any mistake, just let me know so we don't waste time on debugging. طيب, this is all the signals we need, and we need to declare this shift rig. So write shift rig, give it a name, and then we need to put these signals in order. I have clock, reset, load, serial in, DQ, and serial out. Okay, now I need to make my test bench. Let's copy that from the slides. So the first initial begin statement is gonna make the clock for me. We already see this code before, اللي forever loop. Have delay of 10 time units. So forever tick 10, clock equal to not clock. That means every 20 seconds, oh, sorry, every 20 time units, I'm gonna get a clock cycle. This is for the clock. Now for the actual code, let's go with what they had here. Yeah. What's the value of D was 0101 اللي هي 5A صحيح. So D is equal to 8-bit of hex 5A. Serial load equal to 1 at the beginning. Let reset equal to 0 at the beginning. I don't want to reset. What else? Serial in, it started as 1. Keep it that way. Okay. And then we want to wait for maybe up until here, that's 15. So let's wait 15 time units. After 15 time units, we're going to change the value of load to 0. So here, load is equal to 0. Okay. Load equal to 0 at about 15. Is it 15? No, it's about 13. So wait for 13. I'm trying to get the exact figure here. Serial in went down at, let's say 25. So from 12 to 25, that's another 13. So wait for load equal to 0. لا, load equal to 0. That's gonna happen after 13, and then we're gonna wait 13 and put serial in equal to 0. Then this will go on for whatever, 100. About right. This is 100. And let's finish the simulation. let's try it out. Okay, wait, unexpected token, unprintable. What is it? Line 16. ما ادري يمكن مو عاجبه هذه. Still line 16. Clock is equal to 0 forever. Each time unit make clock equal to not clock.
السيمي كولم عند العشرة هذه ولا
احيانا يطلبها، ما ادري. اذا خليتها لاين لحاله يطلبها. هذه عشان في البدايه كلوك will equal to 0. تمام، يعني جيت ارسمها. if you draw it first clock equal to 0، بعدين forever loop tick 10 معناته wait 10 time unit and then make clock equal to not clock, so this will go to 1. بعد كده اللفة الثانية wait 10 time unit and make it 0. wait 10 time unit make it 1. So this should go on forever. Okay. Unprintable token, unexpected token. Reset load, send, rig. Shift rig. UUT. Initial begin, clock equals 0 forever. Begin end. Actually, I'm not sure what's wrong. أنا أقول لك خلينا نلغي هذا كله من هنا إلى هنا and just make sure إنه الكلوك شغال. Okay, so this is all I have. خلي هذه هنا. Let's see. Begin end mismatch at 39. اي هذه ما زال عنده مشكلة في نفس اللاين. task name expected clock. undeclared identifier in. هذا هنا، هذه ما لنا علاقة فيها. ايش ثواني unexpected identifier in design that is v. which line is that? line 6 and line 7.
دكتور
yes.
ممكن يصير واير مفروض في اليسار
الكلوك
الاوتبوت اتوقع.
الاوتبوت it's okay if it was a rig or a wire, that's fine. ولكن انا لغيت كل الكلام هذا الان. انا بس I'm just writing the clock لانه هو اللي فيه المشكله. ف I'm just trying to write a clock, so this should work. يعني هي ما زال في مشكله. anyways I'll try to play with it today and see how we can generate that, and maybe we can come back to this example. I just want to show you the effect of reset when it's synchronous and when it's asynchronous, and to check how it affects our output. But first I'll try to get this figured out. Okay. طيب في أي سؤال يا شباب؟